Hey guys, today we're looking at 6.3, which is Trigonometric Equations Part 2. We're going to continue working with solving trig equations. We are going to step it up just a little bit though. So what's a little bit different this time is it's not just x inside of our sine, cosine, tangent, whatever our trig equation is. This time we might have sine of x over 2 or sine of 2x or something like that. So if I'm looking at our first example, we have 2 sine of x over 2 equals 1. So it says solve it over the interval 0 to 2 pi and for all solutions. So I'm going to kind of start the same way that I did the last problem and just try to get that sine by itself. To do that, I need to divide both sides by 2 to cancel out this 2 that's in front of my sine. So that gets me sine of x over 2 is equal to 1/2. And then I need to get that x over 2 out of the sign. So just like last time, I'm going to do my inverse trig. So I'm going to say x over 2 is equal to my inverse sine of 1/2. And just like last time, I'm going to look on my unit circle and see where on my unit circle do I have an inverse sine of 1/2. Now, remember, you need to look at your interval to see what your answer should be in. So we are 0 to 2 pi, which means we're looking for radians here. So if I'm looking at my unit circle in radians, when I have a sine of 1/2 happens when x over 2 is going to equal pi over 6. And we're also going to have sine of 1/2 when x over 2 is going to equal 5 pi over 6. But we don't have x by itself just yet. So what I'm going to do is I'm going to take that and split it so that I have x over 2 is equal to pi over 6, and x over 2 is equal to the 5 pi over 6, and actually solve those for x. So to do that, all I have to do is multiply both sides by 2. So that gets x by itself, and pi over 6 times 2 would be 2 pi over 6, or pi over 3. Over here, when I multiply both sides by 2, same thing cancels, and I get x is equal to 5 pi over 6 times 2, or 10 pi over 6, which is going to simplify down to 5 pi over 3. So if I'm solving it just over my interval, I would say that x is equal to pi over 3 and 5 pi over 3. So that's just for my interval. Now, this is also going to change a little bit when I write my answer for all solutions. So when I write it for all solutions over here, my all solutions answer, that's not the highlighter, is still going to have the plus something times n, but our period is going to change a little bit. So if you remember from our graphing unit, we had period changes when we were multiplying by something inside of that sign. So our normal period for sine is 2 pi. But remember, if I had sine of bx, I would find the new period by doing 2 pi over b. So I'm going to do the same thing here. Now here I have that it's the sine of x over 2, which means that my b value is 1/2. Remember, if I have x over 2, that's the same thing as 1/2 times x. So to find my new period, I'm going to do 2 pi over 1/2. Or I can do 2 pi times and flip it to over 1, or just 2 pi times 2, which is going to give me 4 pi. So that's my new period that when I write my solution for all solutions, I'm going to do that times n. So I'm going to have x is equal to that pi over 3 plus 4 pi n, and x is equal to the 5 pi over 3 plus 4 pi n. And that would be my answer for all solutions. So when we're talking about solving it this way, there's just some slight adjustments to what we learned in the last set of notes. Okay, let's look at another one. This one, it says solve cosine of 2x is equal to cosine of x over the interval 0 to 2 pi. So once again, we're in radians. This time we just have to solve it over that one interval. So we don't have to worry about the plus something times n here. What's a little bit weird here though is that right here I have a cosine of 2x, but right here I just have a cosine of x. So this is where it gets a little tricky because I don't really um, don't really have the same thing inside my cosines. It's not going to be super easy to solve this. So this is where your identities are going to be super, super helpful. If I'm looking, I know that this cosine of 2x is a double angle identity. So I know when I look at my cosine of 2x, I've got some different options. So if you remember your identities, the cosine identity, the double angle cosine identity, when I'm looking at that, I have the cosine squared of a minus the sine squared of a. So like if I cosine 2a, I could use that. So here, let me write it. Cosine of 2a is equal to cosine squared a minus sine squared a. I could have cosine of 2a is equal to 2 cosine squared of a minus 1. Or I could have that the cosine of 2a is equal to 1 minus 2 sine squared a. So I've got 3 different options that I could pick from. And so you've got to be a little strategic about which one you're going to pick. I'm going to look over here and I'm going to see that it's equal to a cosine x. And remember, our goal here is to get it down to just one trig function that has the same thing on the inside of it so that I can solve this. So I don't really want to use either of these that has sine in it. If it has sine in it, it's not going to be super helpful for me. So the one that has sine, squared, cosine squared minus sine squared, and the one that has the 1 minus 2 sine squared, not really what I want to do. So not there or there. I really just want that one that's got the cosine squared. So that's what I'm going to use here. I'm going to say 2 cosine squared of x minus 1 is going to equal cosine x. Okay, then from here with that squared, cosine squared, that's kind of like some problems we did in our last set of notes. I can move everything to the same side and try and factor it. So I'm going to subtract my cosine x from both sides. So I'm going to have 2 cosine squared x minus cosine x minus 1 is equal to 0. And I'm going to factor. So remember, when we're looking at this, I can do my a times my c on top. So a times c would be negative 2. My b goes on bottom, so negative 1. I need something that multiplies to negative 2 but adds to negative 1, so I would do negative 2 and positive 1. Since I do have that 2 for my a value, that means I've got to split that middle term. So remember, you can also use the u substitution. So let's say that this is like 2y squared minus y minus 1 equals 0. So I'm going to split that, so it's 2y squared minus 2y plus y minus 1. So like this negative 2 is going right here, and this 1 is going right here, equals 0. And then I'm going to factor by grouping, first group and second group. So I can take out a 2y here, and I have y minus 1. I would just take out a 1 as my GCF in the back. So I would have 2y plus 1 and y minus 1. So over here, that would translate to 2 cosine of x plus 1 and cosine of x minus 1. And then I'm going to take both of those and set them equal to 0. So over here, 2 cosine x plus 1 equals 0. Over here, cosine x minus 1 equals 0. For this one, I would subtract 1 from both sides. The 2 cosine x equals -1. Then I can divide both sides by 2. So cosine x equals -1/2. And then I do my inverse. Remember also the -1 notation is not the only way, so let's write this one as arc cosine of -1/2. Just to remind us that there's different ways to see it. And so from here, I would need to look on my unit circle and find what the arc cosine of -1/2 would be. So what angle gives me a cosine of -1/2? We are in radians up here. So x would equal, that's going to be over in quadrant 2, so 2 pi over 3, and in quadrant 3, so 4 pi over 3. Okay, for this one, I would add 1 to both sides. The cosine x equals 1. Then x is going to equal the arc cosine of 1. Cosine is 1 only at 0 or 2 pi. If I look at my interval, 0's got a bracket and 2 pi's got a parentheses. So that means I've got to take the 0. So remember, a bracket means it's an included value, whereas a parentheses means it is not included. So those would be my answers. I'm just going to come over here and write them all together. I would say the 2 pi over 3, the 4 pi over 3, and the 0. And there we go. Okay, we've got 2 more on the back that we're going to look at. So if I'm looking at example 3, it says solve 4 sine theta cosine theta equals the square root of 3 over the interval 0 degrees to 360 degrees for all solutions. So now we are switching to degrees here, and notice it does say for all solutions. So that means we got to do the plus n stuff. Now I have a sine and a cosine here. So this is where it's going to be a little bit trickier to solve it. I need to try and get it down to one trig function if I can, because it's not like I can factor something out here. I can't set it equal to 0 and factor. So if I'm looking at this, I need to try and find an identity that I can use. So if I'm looking at my identities, I'm looking for one that's got like a sine times a cosine somewhere in it. We've got our sum and difference identities, but those all have like a sine times cosine plus cosine times sine or something like that. And we don't really have plus or minus another cosine times sine, so that's not going to be super helpful. Same thing for like the product of sum identities. I do have sine times cosine, but if I use a product of sum identity, then that's going to get me like a cosine of a plus b plus cosine a minus b, or sine of a minus b sine a plus b, something like that. And then I'm splitting theta into like 2 different things, so that's also not going to be super helpful. So probably like a double angle or half angle identity. The half angle identities, they've got square roots in them, and most of them just have like a cosine or a sine in them. But if I look at my double angle identities, I do have the identity that the sine of 2a is equal to 2 sine a cosine a, which doesn't look exactly like what I have right here, but it does look pretty close. What I could do here is instead of 4, I could do 2 times 2 sine theta cosine theta equals the square root of 3. And then I can make that substitution because now they do look the same. So instead of 2 sine theta cosine theta, I can now substitute in sine of 2 theta. So I'm still going to bring this down and have 2, and then it's going to be sine of 2 theta. equals that square root of 3. And then from there, I just need to get that sine part by itself. So I would divide both sides by 2. So I have sine of 2 theta is equal to the square root of 3 over 2. Then I'm going to do my inverse sine. So 2 theta is equal to the inverse sine of root 3 over 2. So I need to figure out where on my unit circle in degrees this time is that going to match up. So 2 theta is going to equal, well, if I'm looking at square root of 3 over 2, that's going to happen. Quadrant 1 is, what, 60 degrees? And sine's also positive in quadrant 2. So that's 120 degrees, 120 degrees. Remember, that's still 2 theta. So I got to come over here and I got to say that 2 theta is equal to 60 degrees and come over here and say that 2 theta is equal to 120 degrees and then actually solve for theta, get theta by itself. So when I do that, I am going to, let's use yellow, I guess. No, yellow's too close to orange. Let's do purple. Divide by 2. So theta is going to equal 30 degrees. And when I divide by 2, theta is going to equal 60 degrees. So I have that theta is equal to 30 degrees and 60 degrees. Okay, now I got to do all of the solutions. And so that's where I've got to go and figure out what my period and if I'm going to adjust that, right? So remember, let's do that in pinkish color. No, let's do it in blue. So the period for pi is, or sorry, for sine is 2 pi. Now I'm looking here and I have 2 theta on the inside. So for my new period, I've got to do the 2 pi over b, and b is going to be that 2 that's in front of the 2 theta. So that means I'm going to have 2 pi divided by 2. The 2's are going to cancel, so my new period's pi. Now, I did all of that in radians because we're used to doing it in radians, but we are dealing with degrees. So if I'm looking at pi, what's going to match up with pi is going to be 180 degrees. So when I write it for all solutions, I would say theta is equal to 30 degrees plus 180 degrees times n. And theta is equal to 60 degrees plus 180 degrees times n. And there's my all solutions. But that does kind of bring up another point here. If we're doing 30 degrees plus 180 times n and 60 degrees plus 180 times n, I don't know that I've necessarily found all of my answers from 0 to 360. So let's look at if n was 1. So over here, theta would equal 30 degrees plus 180 degrees times 1. So that's 30 degrees plus 180 degrees. Well, 30 degrees plus 180 degrees is 210 degrees, which still falls in my interval. So technically, I also have that answer. And what happens if I do the 60 degrees? 60 degrees plus 180 degrees times 1 would be 60 degrees plus 180 degrees, which is 240 degrees, which is also still in that interval. So technically I do have 4 answers here that are in that 0 to 360 interval. So once you do find like all your solutions, it is possible that that could help you find more of your answers that are in your original interval. So I could do 2, and if I try and plug in 2, that's when I would start getting out of my interval. because 180 times 2 would be 360, so 30 degrees plus 360 would get you out of the interval, and 60 degrees plus 360 would get you out of the interval. And let's look at our last example. It says solve tangent 3x plus secant 3x is equal to 2 over our interval 0 to 2 pi. Oh, and there's a typo. Hey, so if I'm looking at this, once again, we've got a tangent and we've got a secant. We need to try and get it down to one of those. So we did one kind of like this last time. I've got a tangent and a secant. Probably the best option for me is my Pythagorean identity. Tangent squared x plus 1 is equal to secant squared x. Okay, I don't have my squareds in my equation, so that means I need to square both sides. Before I do this, though, I probably make my life a lot easier by moving one of them to the other side. So what I would do is I would maybe, um, let's say, since it's like right here, equal to secant squared, let's get that secant by itself. So I'm gonna subtract tangent 3x from both sides. So that's gonna get me secant of 3x is equal to 2 minus tangent of 3x, and that's what I'm going to square. So that gets me secant squared of 3x. And then over here, I've got to write it twice and FOIL it out. So secant squared of 3x is equal to, well, first times first is 4, then minus 2 tangent 3x minus 2 tangent 3x for outside and inside. And last times last is plus tangent squared 3x. Okay, I can make my substitution. I'm going to change that secant squared to a tangent squared of 3x plus 1. I'm also going to combine my like terms here. So 4 minus 4 tangent 3x plus tangent squared 3x. Okay, then I can start trying to maybe move stuff over and see if I can factor. So let me subtract that tangent squared 3x from both sides. And lucky for us, it cancels out. So I've got 1 is equal to 4 minus 4 tangent of 3x. I can subtract 4 from both sides. So 1 minus 4 is what, negative 3. Okay. Then from there, I can divide by negative 4. To blue. So I'm going to get 3/4, now positive, is equal to tangent of 3x. And I'm going to do my inverse. So 3x is equal to the inverse tangent of 3/4. Okay. Also from here, I can kind of tell that that 3/4 is not going to be on my unit circle, so this is going to be a calculator question. So we are solving over the interval 0 to 2 pi. So that means my calculator needs to be in radian mode. And also at this point, I could go ahead and just divide both sides by 3. So I get that x is equal to that inverse tangent of 3/4 over 3 and plug that into my calculator. So make sure you're in radian mode. So if I'm in radian mode and I'm going to plug it in, inverse tangent of 3/4 over 3. And when I plug that in, I get 0.2145. I'm going to round to 4 decimal places for right now. Now, the likelihood of that being my only answer in my 0 to 2 pi interval, really small. So this is where we got to do that period again. So if I'm looking at this, I'm looking at tangent, right? So tangent's what I plugged into my calculator. That's what I'm going to use. The period for tangent was pi. So to find my new period, I need to take that and I'm going to divide it by b. Well, my b value is that 3 that was with that x, right? So pi over 3. So when I plug that into my calculator, I get 1.261. Okay, that's probably not the only answer there. So let's plug it in again. Add another pi over 3. I get 2.309. Add pi over 3 again. Gives me 3.356. Probably still got something else. So add pi over 3 again. Gets me 4.403. Let's try adding one more time. That gets me 5.450. It would help if I could write. My pen is not wanting to connect right now. That's why I keep kind of having awkward pauses in the video. Sorry. Okay, so we've got kind of a lot of answers here. And if I try to add pi over 3 again, I think that's going to be what pushes, yeah, that one pushes me out of my interval. And from here, it is a good idea to check your answers and plug them back in and see if they actually work in your equation. So if I try to type in that tangent of 3 times that, let's say 1.261 plus, so we don't have a secant button on our calculator, but remember secant is 1 over cosine. So I can put 1 over cosine of that 3 times 1.261 in my calculator. And if I plug that one in, I end up with a negative value, and that is not 2, obviously. So that one's going to be an extraneous solution. So that's not going to work. And so you can kind of go through and check your answers just to double check and make sure that they work. Because when you do have a problem that looks like this, where you've got like a tangent and a secant and you've changed it, sometimes your answers will work and sometimes they won't when you've got these calculator problems. So when I do this one, the 0.2145 works. That one doesn't. The 2.309 works. That one doesn't, and the 4.43 works, and that one doesn't. So my answers here are 0.21, I'll say 215, the 2.309, and the 4.403. And there are my answers. Okay, that's it for this set of notes. Let me know if you have any questions. Make sure you get started on your assignment that goes with this, and y'all have a good day.